Compound inequalities are inequalities that have two inequalities in them, which is why they're compound. And the words that you see in a compound inequality are or the word and. And you will typically see one of those two words. You may not see one of those two words, and I'll show you an example where you wouldn't. But a compound inequality is when you take two separate inequalities and you put them together, either using the word and or, and can be written like this because you're joining the two things together, and or is going to be written separately. Now, the reason that we talk about them is, for example, this is saying x is greater than or equal to -2, and this is saying x is less than 5. When you write it like this, saying x is greater than or equal to 2 and x is less than 5, you're not just talking about all the numbers in each of the groups. You're talking about a specific amount of numbers or a specific range of numbers that meet both of the rules. And it's a smaller quantity, obviously, and this is that compound inequality. Over here, we're compounding a less than or equal to -2 and a greater than 1, and we're compounding it and saying, well, or means at least you're in one of the categories. So for example, over here, I have to be in both groups in order to be a solution. In this one, as long as I'm in one of the groups, I'm okay. I'm part of the solution. So this one, I had a teacher I used to work with, and he called this wings because it kind of made him think of like bird wings going in different directions. And he called this one strings. And so that's how he described compound inequalities, talking about wings and strings. Let's look at example 1. We just have to write them and then graph them. A number x is greater than -8, and it's also less than or equal to 4. Now you can write it like this, but you typically won't see it written like this. You'll typically see it with the joining because ands can be joined. So you'll see it written as x is greater than -8 and x is less than or equal to 4. This is probably the better way to write it, but it's okay to write it broken up. And now we graph it, and because we're talking about an and, it's going to be one of our strings. So it's going to be in between -8 and 4, with an open circle around -8 and a closed circle around +4. Letter B. A number y is at most 0 or at least 7. Because this is an or, you can't join it, so you have to keep it separated. Graphing it, it's going to be a closed circle around both 0 and 7, and since it's an or, we're going to go in other directions. Also, you want to not so much or, you want to pay attention to the symbols. This is less than or equal to 0, and this is greater than or equal to 7. So that's really what determines the direction, not necessarily and or. It's the symbols. So now let's actually solve one. So you can solve them by doing just what we've done before with dropping the line down the symbol. But now you have two symbols, so you're going to drop two lines. So I'm going to look at the inside, and I'm going to do exactly what it says to do, only inverse. So I'm going to subtract 1, and then I write down what I got. -4 is less than, those cancel, -2x less than or equal to 8. Last thing to do is to divide everything by -2. So you get 2. Oh, wait, I divided by a negative, which means all the signs have to change direction. So this turns greater than, I almost forgot that. And this turns to x. This changes direction to greater than or equal, and that's -4. So there's my solution, and since it's an and, because it's written like this, then it's going to be between the two values. So x is greater than -4, or equal to -4, and less than 2. So it's written backwards because I had to flip the symbol, but obviously you would do the number line in the correct order. An open circle, and it's joining these two pieces. So we're solving an OR statement in this question, example 3. So since you can't join ORs, you have to just solve them one at a time. So plus 5, 3x is less than negative 3. Since the 3 that's being divided on the bottom is not negative, I don't have to flip the sign. Or 2x minus 1 is greater than 5, plus 1. 2x is greater than 6. X is greater than 3. So I've got these two inequalities are representing my solution. And I have to graph negative 1 and 3. So I'm less than negative 1. Or I could be greater than 3. Both of these are happening, so this is that wings situation where they're going in different directions. Typically, the ors go in different directions, and the ands go in the middle. There's one other type of compound inequality, and it's called an absolute value inequality. And it's an inequality, obviously, that has an absolute value. So this is probably one of the most basic ones. We're going to obviously deal with more complex ones. But the absolute value inequality, remember absolute value, the absolute value of, let's say, 4 is 4. But the absolute value of negative 4 is also 4. So absolute values kind of have two answers, and so this is why it's in the compound inequality section, because since you could have two answers, you can also create two inequalities. So we still get those wings and strings. And there's a little tip over here that I want you to read. I'm not going to read it to you, but I do want you to look at that. It is very helpful when you're trying to figure out how to decide what your symbols are and what your word is. So let's solve example 4. When you're solving absolute value inequalities, like we're going to do in a moment in example 4, you want to look up here and you want to have the understanding that there are really two answers. So this value inside the absolute value symbol could be positive, as we know, but it could also be negative. So this value in here is either negative or positive. So we have to solve it as if it were negative, and then we have to solve it as if it were positive, because I don't know what this value is. All I know is that it's either positive or negative. So here's what I do. I do a little split up, and I say one possible solution is that it's less than or equal to 2. And you remove the absolute value signs, the little vertical lines. The other possibility is that it represents the negative number. Now, when you write the negative number, you have to flip the symbol because you're dealing with the negative and you're changing it as we've done before. So these are the two inequalities. I want you to look at the difference between the original question and the inequalities that we wrote. We've taken this inside of the absolute value. We've said this value either represents positive 2 or it represents negative 2. And when we changed the sign, we had to flip the symbol. So let's solve them. They're simple one steps. Minus 7. And over here, you will not normally get the same number, so you can't just say, oh, well, if one is negative 5, the other's positive 5. It doesn't work like that. So these are our two solutions. And using the study tip that I told you about earlier, this is representing an AND situation. So you can join them if you want, or you can leave them separate. It's up to you. I'm going to join them just so you know what it looks like joined. And then we have to graph it. So I didn't really leave myself a lot of room. Negative 9, negative 5, since it's colored in the middle, and it's going to be a strings, so you color in the middle. Let's look over at letter B. The absolute value of 8x minus 11 is less than 0. Well, this is actually a trick question, because when you do the math, you will never get a number that's less than 0. You can plug in a number less than 0, but you will never get a number out of the absolute value that's less than 0, right? Absolute value always ends up with the positive number. So this one officially has no solution. So be on the lookout for trick questions. They don't happen often, but every now and then you want to be prepared. In letter C, we have a lot of things going on. We've got multiplication, we've got addition. Just like if I had the equation 4x plus 1 is greater than 29, we would say, well, get everything away from the x, right? Subtract 1 and then divide by 4. You want to treat the absolute value as the x. You want to say, I can't touch it until everything is on the other side. So I can't touch that 2x minus 5. I can't split it up like I've done in the past until the 1 goes away and the 4 goes away. So I got 4 times absolute value is greater than 28. I still can't touch the absolute value until I get rid of the 4. All right, there we go. Now that the absolute value is totally by itself, like the x was, now I can split it up and solve. When I split it, on the second time, not only does the 7 turn to a negative, because it could be negative 7. I don't know what this value is. It could be 7 or negative 7. But the symbol also has to change direction. So add 5 and divide by 2. The procedure is the same for solving, but the answer is almost never going to be the same. Using my tip from the study information up top, this is an OR situation. And last thing I have to do is graph. So I've got -1 and 6. Open circle around both, but this is going to be a wings because it's an OR. I'm going to start you off with this one, and then I'm going to ask you to pause the video and solve it on your own. So pause the video first and just read the story. All right, so I'm going to start you off with the words, translating it, and then you're going to solve it on your own. So if we have the actual percent of voters being the mystery value that we're trying to find, x minus the percent of voters in the poll, which is 47, the absolute value of that is less than or equal to the margin of error, which is 2. So why don't you pause the video and try and solve that on your own. So writing one of these, obviously, I think, is a little complex. So we'll just focus on the basics for now. But this is a real-life example. And if you have any questions, please write them down. We will definitely spend a while going over this in class. I know there was a lot of information to take in, and I'll see you then.